All right, a short module about the Linux kernel. Again, this is an online class where I couldn't really comfortably require you all to build your own Linux machines, so we have to kind of hand wave a little bit of some of this hardware stuff. But at least with the kernel, there are some things we can do. We can look at what's going on with the kernel. We just don't want to make changes in the cyber range. That would be exceptionally bad. So again, only a few slides, but we are going to get a little bit more into some Linux-y stuff with this. We're going to look at the kernel. We're going to understand the steps to install, configure, and monitor. Because we're working in the range, we're not going to do the install or configure very much, but we'll definitely look at some of the monitoring that we have to do. So this comes with the big warning of please be careful if you're doing anything with a kernel. You can really just totally destroy your machine. You'd have to reinstall everything. And in the cyber range, I'll warn you if we're going to do anything you shouldn't do. I think I've stripped all the really dangerous stuff out of these slides, so we're mostly just looking at configuration stuff or monitoring stuff. But you want to be really, really careful. You don't want to make changes to your kernel in the cyber range because it'll break the cyber range, or at least your connection to the cyber range. So what is a kernel? Kernel is the core. It's that juicy center of an operating system. It manages all of the other systems. So the kernel is kind of the brain, right? It takes care of your hardware, memory, file access, what processes are running, all of your I/O. The kernel is kind of the heartbeat. I'm looking for a better metaphor, but I think I've given all of them to you. Right, so it's the first thing that loads when your system starts up. So you always load a kernel, and your kernels can be different depending on what operating system you're using. So kernels are divided up usually into two spaces, and we don't really think about those spaces in physical ways, but it's important to understand that they're there. Basically, we have services run by the kernel, and then we have everything else. All right, so your kernel space is your modules, drivers, and services, and then your user space is like all the stuff that's happening. So all this stuff passes through there, and it gets managed and dealt with. And this provides some security because it prevents things from running in the user space from inadvertently making changes to or through a kernel. Because that could be bad. So two major kinds of kernel, and these are not perfect one-to-one descriptions, but they're generally true. So a monolithic kernel tends to be all system modules, drivers, devices, and it all runs in the kernel space. It tends to be built to work fast. It tends to be a little less stable because there's so much stuff, right? Anytime you start adding things to anything, you start adding complexity, you start reducing the stability, and you tend to increase the size. Now these are not necessarily good or bad, right? There are reasons to have a monolithic or a microkernel. These are just kind of the gives and takes that occur with them. A microkernel typically is just a cut down kernel. It's just what you gotta have to run. Nothing more, nothing less. So microkernels, a good example of microkernels to be used in small portable devices, like IoT devices. The more you can throw away unnecessary services, right? I don't need a web server in my watch, right? So getting all of those unnecessary services out makes it very small, tends to make it very stable. It tends to have relatively poor performance. The word relatively is important here because typically it has very good performance specifically for what it's built for. It has relatively performance doing anything other than what it was specifically built for. So the Linux kernel is a monolithic kernel by default. People do build microkernel versions. Again, there's no perfect one-to-one on all of this, but the Linux kernel is a monolithic kernel. It means it's got a bunch of stuff, right? So when you install the kernel, it comes with a lot of these calls that you can use to do I/O and all of those things. The kernel is modular, meaning that you can add and subtract from the kernel. And the kernel itself is open source. This means that you can change it. Now, you can take an open source version of the kernel and essentially close source it. There are some rules associated with what you must and must not and don't have to share and that kind of thing. But generally speaking, it's open source, which means that the root hunk of kernel, even if you close source around it, that root hunk of kernel is still open source. It means it's very customizable. That's why you see so many different Linux variants. And I don't mean just Ubuntu and CentOS and that, but like IoT devices will run their own custom kernel. Security devices will run their own custom kernel. So there's a lot of customization available. Typically, you can see it's named with a major and a minor and a patch. This varies from kernel to kernel version, type, that kind of thing. But usually, this is what you're going to find: major, minor. So, for instance, you might see 18.04.01, major, minor, and whatever patch. Major versions are fairly rare. They're usually a big deal. Minor versions happen a good deal more often, and patches happen in theory constantly if you're using a good operating system. And new kernel work is always underway. So for instance, back in July, they were working on 5.2.1. I think the current kernel is like 4.7, something like that. So we're already working way ahead to try to build significant additions to the kernel. I may be totally wrong about that kernel number. Note that the kernel is not the same as distributions, right? So when I look at Ubuntu 18.4.1, major, minor, patch, but that's not the kernel that's being used. The kernel may be 4.7, 4.8, 4.9, 5.0, I don't know. But that's different than the actual distribution that you're working with. So if you want to know stuff, and this stuff's okay to do in the range, we've already kind of looked at some of this. We can ls mod and see what we've got and what we're dealing with. Right, and we can see all the loaded modules that are there. These are the things that are running and operable and what they do. Nice to see I've got a floppy here. I'm not quite sure what that's doing in this case. And of course, if we have lots and lots of modules, we could use grep to see what they are. And of course, if you were to use this dmest, as you saw in the last module, assuming you watched it, you can actually see the kernel's buffer. That thing is constantly being updated. I'm going to pipe it to less, otherwise it'll be overwhelming. And if we go all the way to the bottom, if you compare this to the last video, you should see that this is a little bit different here at the bottom than it was just a few minutes ago, in theory. All right, so talking about the layers of a kernel, right? So a kernel has functions, operations. Each of these things kind of sits in a layer, if it will. And these layers are sort of important to know and understand. So system call interface. So the SCI handles calls from an application to the kernel. So when I say, hey, dmessage less, that's got to go through the SCI so the kernel can go, oh yeah, let me show you that. Okay. Process management. So this is timing on a processor. So a processor can only do one thing at a time. Even when you're multitasking, it's actually not really multitasking. It's multiple processors doing multiple things. Each one can only do one thing at a time. So you have this timer, this heartbeat, if you will, that says, yeah, let that go through, 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 yeah, right? And that's timing, that's process management. It decides who gets what, when. And in some cases, it may decide that, well, this process gets all of the timing for a while, and this process just has to sit and wait. Memory management, it's all right there in the name. Same with file system management and device management. Each of those is a layer of the kernel that's actually out there and operating and functioning and doing stuff. So don't do this in the cyber range. Don't do it. All right. So we can add and remove modules in the cyber range to do that. Don't do it. All right. All right. Now you can look at them if you want. So if I wanted to do syscontrol syctl, I can look at it. That's okay, assuming it actually worked. Yeah. Just try that again. Sysctl-a. Right. Okay, I'd have to sudo. Makes good sense. Nah, it's not in there. They've even taken it out to protect me from myself. All right, so we can look at that. Let's get crazy here. Let's bounce over here and see. That's not what I want. I want change this to all right, that's not pretty, but we can at least see it. I should be able to run some of these here. Well, if I run syscontrol, see if it's installed on this one. L. I actually don't know if it is or not. There we go. So now we can see, and I really should have done it less. We can see these things that are actually going on. Again, you don't want to go screwing with these things unless you really want to be messing with them, right? But you can see exactly what modules are running and what they can do. And as you can see, there's a lot of stuff here, as you might guess by looking at them, like IPv6, IPv4. We can probably guess those are networking, right? So there's lots of stuff you can get into, not on the cyber range, thank you very much, but within syscontrol, and kind of poke around and see what's going on. Do not run these mod probe commands on the cyber range, thank you. All right, so monitoring's totally okay. So if we were to right, so we can take a look at with help if I actually typed these things right. I'm gonna get there. I know I am. See, I'm not the only one that has to try these things 100 times. So there's some stuff we can figure out, and there's some stuff that we can't. We can see down here there definitely is a process running. Process is blocked, right? And we can look at let's do the same thing with file systems. Right, we can see what kind of file systems we can deal with here, and of course the version compiled. We can see that, oh, there we go. In this case, we can see that this is kernel 3.13. That's an older kernel, and we can see it's Ubuntu is it's not Ubuntu 4, but we can see a little bit about it by looking at those things. So this is how we can kind of see what's going on in the kernel, what modules we've got, and what's happening with them. We've already played with these. Again, it's just the same old. If you want to look at what you got, you can uname, and these are, of course, okay to see what you've got. And if you want to know everything, you certainly would uname A. And let's get everything. And again, the same kind of stuff that you can find from the other one, everything that's out there. Make sense? So those are easy, quick, simple things that you can do to look at the processor, kind of start understanding the concept. Again, if you really want to understand it, you'll install your own version of Linux and you'll mess with the processor. That's really the only way to get in there. Just don't do it on the cyber range.